Now in this video we will basically discuss basics of mole, and then we will discuss how a chemical reaction, balanced chemical reaction, can be used to find mole of reactant or mole of product. So let us first discuss about mole. What is mole? And the very simple answer is mole is a counting unit. So mole is a counting unit. Basically, mole is the SI unit for amount of substances also. So mole is the SI unit for amount of substance also. And 1 mole is defined as number of atoms in 12 gram of C12 isotopes. So 1 mole is defined as number of carbon atom in 12 gram of C12. Now what is the meaning of C12? Let us first discuss. And to discuss C12 I have to have a concept of isotope. What is isotope? If I see the carbon atom, there are many kind of carbon atom is available in the universe. One kind of carbon atom contains 6 proton and 6 neutron. So it has 6 proton and 6 neutron. So this has 6 proton and 6 neutron. Another kind of carbon atom inside the nucleus, they also have electrons. So I am not showing electrons. So they have electrons also. I am not showing electrons. This carbon atom also contains 6 proton, but now they contains 7 neutron. Another carbon atom contains 6 proton but 8 neutron. So there are 3 kind of carbon atom. They have same number of proton but they have different number of neutron. So carbon atoms are having same number of proton but different number of neutrons. Now we call this as a atomic number. So atomic number is defined as number of proton. So this is number of proton, and it is simply written as Z. So Z is equals to P, number of proton. Now we define mass number, and this is defined as number of proton plus neutron, and in short this is denoted by A. A is equals to number of proton plus number of neutron. So this is 1, this is 2. Now if I subtract 1 from 2, so we can write A minus Z is equals to number of neutrons. So we have a relationship. If you subtract atomic number from mass number, so this is your mass number, and if you subtract atomic number from the mass number, so finally we'll have number of neutron. So this is number of neutron. Now we define isotope that has same number of proton but different number of neutron. This means isotopes are a species that have same atomic number but different mass number. So what is isotope? Isotope, a species or atom that has same number of proton, same number of proton but different number of neutron. Now when I say carbon 12, this has a isotope, this one, that is 6 proton 6 neutron. So this is carbon 12. And now this is 6 carbon 13 because mass number is carbon 13, 6 plus 7 13. Now this is carbon 14. So when I say 12 gram of C12, this means I have to take carbon 12. So now 1 mole is defined as number of carbon atom in 12 gram of C12, and it is found to be 1 mole is equals to 6.023 into 10 to the power 23 unit. It's like dozen, like when I say dozen, this means it has 12 unit. Similarly, when I say 1 mole, this means 6.023 into 10 to the power 23. It can be anything, the unit can be anything. You can have a mango, you can have banana, you can have atom, you can have, so anything is possible. Unit can be anything. You can have, let us say, mango, you can have pen, you can have atom, you can have molecule, or you can have ion. So anything is possible. Now 1 mole is a special kind of unit. So when I say 1 dozen of banana, so when I say 1 dozen of banana, this means 12 banana. So this only gives you numbers. But now if I say all bananas are identical, so if I say all banana are identical and each has mass of 100 gram, and each has mass 100 gram. In that case, I can say 1 dozen banana will also have a fixed weight, that is 1200 gram. So in that case, I can say 1 dozen banana will have 1200 gram weight. So if each bananas are identical, not only numbers, we can also say something about weight, and that is true for atom. So if I say 1 mole of carbon atom, 1 mole of carbon atom or 1 mole of sodium atom, all sodium atom are alike, one time of sodium atom, and all have same mass. So all sodium atom are alike and they all have same mass. So when I say 1 mole of sodium atom, this also tells me about weight, that is 23 gram. So two things is important. So when I say 1 mole, it has to say something about numbers, that is 6.023 into 10 to the power 23. It also says something about weight, and this weight is mass of 1 mole of substance, that is called molar mass. So let us discuss more about molar mass. So what is molar mass? This is defined as mass of 1 mole of substance. So mass of 1 mole of substance, we'll call this as a 1 mole. If this is a atom, then we will call atomic weight or atomic mass. If it is molecule, we will call this as a molecular mass or molecular weight. If it is formula unit, we will call this as a formula weight. So this means what is atomic weight? So this is weight of 1 mole of atom. 1 mole of atom. What is molecular weight? This is weight of 1 mole of molecule. And then what is mole formula weight? So this is 1 mole of formula unit. So this is formula unit. So weight of 1 mole of formula unit is called formula weight. So this is about molar mass. So when I say 1 mole, weight of 1 mole is fixed, and this is equals to molar mass, and this will depend upon type of atom. If I have sodium atom, if I have calcium atom, both are not same type, both have different weight. So 1 mole have different weight for different substances. This means this thing, that is the weight, it will depend upon identity of atom. So it will depend upon identity. But this thing, that is number, this is always fixed. Either you take sodium or you take calcium or you take potassium, always this number is 6.023 into 10 to the power 23. So this does not depend upon identity. Now 1 mole does not say only about numbers or weight. So 1 mole says about numbers, that is 6.023 into 10 to the power 23. It says about weight, that is equals to molar mass. It says about volume also. So it says about volume also. And this is true when we have gaseous substances at STP. And the volume is 22.4 liter. So if I have 1 mole of hydrogen, helium, so if I have 1 mole of hydrogen or helium or oxygen and all are at STP, they all will have same volume, and that is 22.4 liter. So this means this is once again does not depend upon identity. Either you take any gas, 1 mole of any gas STP, they will always occupy 22.4 liter. So does not depend upon identity. Does not depend upon identity. So this will does not depend upon identity. So you see, 1 mole is basically a special kind of unit. So when I say 1 mole, this says about number, this says about weight, this says about volume also. So mole is so basically I can say mole is a special kind of counting unit. A special kind of counting unit that says about numbers, weight as well as volume. And the volume only if the substance is gas. If you are liquid and gas, 1 mole substance will have different volume. Let us say if I have 1 mole of water, it will not have 22.4 liters. So 1 mole of water, what is the weight of 1 mole of water? So 18 gram is a molecular weight. So 1 mole of water will have 18 gram, and we know density of water is 1 gram per ml. So this is 18 ml. So 1 mole of water will have very less volume, only 18 ml, but 1 mole of gas will have 22.4 liter, that is 22400 milliliter. So 1 mole of liquid or gas will not have same volume. So 1 mole of liquid and gas will have very less volume, will have very less volume, because in liquid and solid molecules are very close. So if I have a liquid and solid, so this is, let us say, this is my liquid part, molecules are slightly away, and this is my solid, molecules are very close. So in case of liquid, molecules are slightly apart, but in case of solid, molecules are very close. This is your liquid. In case of gases, molecules are even very apart. So this is gas, molecules are very apart. Now let us use these three things, that is the numbers, weight and volume. We can convert. So if I have been given, so let us discuss about mole map. And this is very easy. If I give you weight of any substance, you can always convert this into mole. And this is easy to convert. If you divide weight divided by molecular mass, molecular weight, this will give you mole. Like if I say 46 gram of sodium, what is the mole? So atomic mass in this case is 23. So if I divide by 23, this will give you 2 mole. So we have to divide by molecular weight or atomic weight, basically molar mass. It will be better word, molar mass. So if I divide this by molar mass, then we will get mole. Now if number, so if weight is given, we have to divide by molar mass. If numbers is given, once again we can divide by Avogadro number to get the mole. If volume is given, then we can divide this by 22.4 liter to get the mole, and this is for gas at STP. What is STP? That is a standard temperature and pressure. We will discuss this in gas law chapter. Now once I know the mole, we can reconvert mole into weight, multiply this by molar mass. We can convert mole into numbers, multiply by Avogadro number. We can convert this into volume, mole into volume, simply multiply by 22.4 liter, and this is at STP. For gaseous substances, this is true at STP. So this means now we can have 2-3 kind of calculation. If I give you weight, you can convert into volume, numbers or weight. So if I say convert 26 gram or 36 gram of sodium into numbers, so what you have to do? First convert weight to mole and then mole to number. So we can basically have this kind of conversion. We can convert weight to number, and we have to go via mole. So anything we have to first convert into mole. We can convert volume to numbers. Once again we have to go via mole. So first we have to find mole and then we have to find number. So this kind of calculation we can perform on weight, numbers and volume. So we can play with the three variable with mole, that is weight, numbers and volume. Now next thing we will discuss what are the information we can obtain from a balanced chemical equation. So let us say we have combustion of glucose C6H12O6 plus O2, and this gives you CO2 plus H2O. So first task is balance this chemical equation. So we have 6 carbon here, multiply by 6. We have 12 hydrogen here, multiply by 6. And now we have 6 oxygen plus 6 into 2, 12 oxygen. So total we have 18 oxygen. So 6 into 6, if I multiply 12 plus 6, 18 oxygen, coefficient is 1. Now this is a balanced chemical equation. So whenever you have been equation is given, first task is balance the given chemical equation. So first task, you have to balance the chemical equation. So now we have balanced chemical equation C6H12O6 plus 6O2, and this gives you 6CO2 plus 6H2O. Now the question is, what this balanced chemical equation suggests? What are the information contained inside this balanced chemical equation? Now this information can be looked or can be seen microscopically as well as macroscopically. So if I look this information microscopically, that is in terms of atom or molecule, or in terms of mass, so mass of one atom or molecule is given in AMU. So this is a microscopic picture. Let us discuss first microscopic in terms of numbers. So I can say when one molecule of glucose reacts, so when one molecule of glucose react, at the same time 6 molecule of oxygen reacts, at the same time 6 molecule of CO2 reacts, and 6 molecule of H2O reacts. If you count total number of atom this side and total number of atom this side, I am not saying molecule, I am saying atom. So this side you have 12 plus 6, 18 plus 6, 24 plus 12. So we have total 36 atom. Now if you count total atom this side, 6 into 2, 12 plus 6, 18, and this side again 18, so you have total 36 atom. So if you see the total number of atom left side is equal to total number of atom right side, this basically holds law of conservation of atom. So law of conservation of atom. That is, in any chemical reaction, atom can neither be created or not, it can be destroyed. So in any chemical reaction, atom can neither be created, or and cannot be destroyed. Chemical reaction is simply redistribution of atom. So if you see what is happening in chemical reaction, so if you have this kind of two atom AA, and here you have BB atom, after this reaction you have AB atom and AB atom. So basically what has happened, this atom initially attached to A like atom, now it is attached to B like atom. That is redistribution of atom. So chemical reaction is simply redistribution of atoms. So this is simply redistribution of atom. Now we have talked in terms of number, let us talk in terms of weight. So I can write equation once again. So I have C6H12O6 plus 6O2, and this is giving you 6CO2 plus 6H2O. Now let us talk in terms of weight. So what is the weight of 1 mole of glucose? So this is, so we are talking in terms of weight microscopically. So this is 180 AMU, and this is 40, so this is 16 into 32 into 6, so 32 into 6 gram, and AMU, sorry, 36 into 6 AMU. And what is the mass here? So this is 6 into 44 AMU, and this is 6 into 18 AMU. Now let us add these two masses this side and add these two masses this side. So you will find these two masses are same. Basically you can add. So if you add these two, this comes out to be 372 AMU. And this side also you will find this comes out to be 372 AMU. This means left side mass is equals to right side mass. So in any chemical reaction there is no loss of mass. That is, balanced chemical reaction also obey the law of mass conservation. So I can say balanced chemical reaction obey the law of mass conservation. Now we can also talk macroscopically. Same equation can be also think or thought macroscopically. So macroscopically, if I see C6H12O6 plus 6O2, and this will give you 6CO2 plus 6H2O. In this case I can say 1 mole of glucose. So when 1 mole of glucose reacts, 6 mole of O2 reacts, same time 6 mole of CO2 reacts, and 6 mole of H2O reacts. That is big picture. When I say macroscopic, I am talking in terms of mole, gram. That is big picture. So I am talking in terms of big picture. So when I say 1 mole of glucose, mass is 180 grams. So 180 gram glucose reacts. At the same time 6 into 32 gram of oxygen reacts, and 6 into 44 gram of CO2 reacts, and 6 into 18 gram of H2O gets formed. So this is a equation. So these are the information contained in a balanced chemical equation. Now this balanced chemical equation can be used to solve the numerical problems. Now these coefficient 1, 6, 6, 6 are called molar ratios. So coefficient of reactant on product is called molar ratio, or this is also called a stoichiometric coefficient. So coefficient of reactant or product is called molar ratio. In other words, this is same as a stoichiometric coefficient. So this is also called a stoichiometric coefficient. Now what are the relation? So this means this ratio gives you in which ratio, mole ratio. So if I have 1 mole of this, same time 6 mole of this, 6 mole of this, 6 mole of this. This means now I can use this information to get the mole of reactant on product if mole of anything is given. C6H12O6 plus 6O2, 6CO2 plus 6H2O. Let us say if I give you 5 mole of, or let us say 5 mole of oxygen, what is the mole of glucose that will react with 5 mole of oxygen? So this is the question. 5 mole of oxygen, 5 mole of O2 will react with how many mole of glucose? How many mole of glucose? So you see 6 mole of oxygen reacts with 1 mole of glucose. So 1 mole of oxygen will react with 1 by 6 mole of glucose. So 5 mole will react with 5 by 6 mole of glucose. Are you getting or not? So what we are doing? 6 mole of oxygen reacts with 1 mole of glucose, and this is given here, glucose C6H12O6. So 1 mole of oxygen will react with 1 by 6 mole of glucose. So 5 mole of oxygen will react with 5 by 6 mole of glucose. So what we are doing, we are using this molar ratio, that is 1 by 6. So this is molar ratio, ratio of moles. So we can use molar ratio to calculate mole of another reactant. So this means if I know mole of one substance or mole of reactant, we can use molar ratio to calculate mole of product. Other is also true. If mole of product is given, we can calculate mole of reactant. Now there are many ways to give mole of reactant. If I give you weight, you can divide by molecular weight to get the mole of reactant. If I give you numbers, you can divide by Avogadro number to get the mole of reactant. If I give you volume, we can divide by 22.4 to get the mole of reactant. Similarly, if I have mole of product, we can multiply by molecular weight to get the weight of product. We can multiply by Avogadro number to get the numbers of product. We can multiply by 22.4 liter to get the volume of product for gaseous substances at STP. There is one more way to give the mole of reactant, and that is molarity times volume. So if I give you molarity and volume, mole can be calculated molarity into volume. So we have a formula, number of moles is equals to molarity into volume. So this we will discuss in the later chapter. So molarity into volume is also give you mole of reactant. Now if I know the mole of product and if I know the volume, so mole of product and volume is known, we can calculate molarity. So molarity is nothing but N by V, because we know number of mole of product, we know the volume. Other way also, if we know molarity, then we can calculate volume. So in this case, if I know molarity, so molarity is known this time and volume is unknown, so number of mole divided by molarity, this will give you volume. So these are the kind of information that we can obtain from balanced chemical reaction. Now this is a, when molarity and volume is given, this is a basically case of solution stoichiometry, that is molarity is defined for solution. So this is a case for solution stoichiometry. So when we have solution stoichiometry calculation, molarity and volume will be given.